I'm here at Rode with Ryan Burke, who's like the resident genius on all things microphones here. He's also the export sales manager, but he's been giving us an incredible education on what happens here. We're in this awesome place. It's really, really loud here. What are they doing here?
What an introduction. Well, in here is kind of the birth of the microphones. This is where they first start out. This is the machine room where we'll actually machine the backplates for capsules. We'll machine the bodies of shotgun microphones and the kind of smaller miniature microphones. And basically any of the spines for the inserts of the microphones as well. So this is where, you know, a microphone comes from like a raw material, like a brass or an aluminium, and becomes a microphone.
Wow. Can you show us what some of this looks like?
Yeah, sure. So right here you can see some of the finished products. So one of the more interesting ones, you can see the brass raw body of an NTG3 here.
So this is an NTG3.
That's an NTG3.
Before it's painted and everything else.
Exactly right. So what will happen to this after this stage? It starts as like a solid brass bar. It gets machined in these lathes here, the big long lathes. And then what happens is that'll get glass bead blasted to give it a nice kind of surface area, and then it'll either get ceramic coated or it'll get plated, depending on whether it's the silver or the black version.
Wow. So then you basically put the capsule, it fits in there, the electronics go down there.
Yep.
Wow.
The XLR pod goes into the end there.
And
there's your the start of a shotgun microphone.
Beautiful.
Some of the other stuff that we've got here at the moment. This is the bodies of the Video Micro.
Right.
Video Mic Me, so this is the one that you can use for iOS devices for filming.
Sure.
With like a little short kind of interference tube at the back, just to kind of give a bit more directionality to the high frequencies. This is the same kind of design, but that's for on camera, so that's a Video Micro.
Right.
And you can see, I mean, this is a microphone that comes in at a really low cost at the kind of retail level, but it's still machined on the same kind of lathe that we make our really kind of premium microphones on.
And this is aluminum.
Yeah.
Aluminium.
Aluminium.
Right.
Yeah, that's it. Depends on where you're at.
Where you're at in the world. Yeah.
Exactly right.
Beautiful.
Yeah, cool. So let's have a bit of a look at the process. So you can see here, this is the kind of material that goes into the machine. It's a solid bar, and then we'll actually remove material using this machine here. They're about 3 meters long, so about kind of 10 feet long. The bars that go into the machine. And what happens is we set these up, and they can run 24 hours a day.
Wow.
So we can set them up, you load in a whole bunch of bars, and they'll just keep running through, keep producing microphone bodies or whatever part they're making.
How many of these can they make in an hour?
Oh, geez. It depends on the
there's
product.
stuff coming out there, right there.
Yeah. So you've seen the swarf come out there. It entirely depends on the product and the complexity. So some parts might take up to 12 minutes to machine.
Oh, wow.
Others will be done, in a few seconds. If it's a smaller part, something like this might be a couple of minutes. It entirely depends on the design of the part. So,
wow.
it can actually be one of the big bottlenecks with manufacturing is how long does it take a particular part to be machined? Because as you can imagine, 12 minutes, for instance, for the spine of a particular microphone, you can't do a whole lot within a 24-hour period, so you need more machines then.
So how many of these machines do you have?
So we've got, it grows every time I'm in here. We've got 6 at the moment.
Right.
Within a few months, we'll probably have 8.
Wow.
We've always got another one on order, because it actually takes quite a while to get them spec'd up and brought into the factory. So, I mean, I went away on a business trip and came back and these 2 were here. So it's kind of like it's growing pretty fast.
Wow.
Yeah.
Amazing.
Yeah.
Well, then what happens after all this?
Cool. So I'll see if I can find a backplate and show you that side of it as well. It looks like we're not manufacturing backplates at the moment.
Yeah.
But we also manufacture the brass backplates before they get machined to their final finish in here. And what happens from here is they go into our other main manufacturing facility just next door, where we'll actually start turning them into a real microphone.
Awesome.
So let's go check it out.
Let's check it out.
Yeah. All right, so this room is our transformer manufacturing room.
Yeah, I can see all this awesome copper. They look like giant magnets everywhere.
Yeah, exactly right. So, I mean, this is the newest space at Rode. We started manufacturing transformers for our NTR ribbon mic.
Yep.
This is the Rode TR1 transformer.
That is heavy.
Yeah. So one of the challenges we had with bringing out a really nice ribbon mic was that transformers can be very expensive to get a really well-spec'd transformer, and that's something that's got a really low impedance so that you don't have, the signal trying really hard to get through the transformer and then having a lot of noise. So ribbon microphones are traditionally really noisy. Our ribbon mic has 15 dBA of self-noise, which is less than a lot of other manufacturers' condenser mics,
Wow.
which should be a lot quieter.
Should be, right.
Yeah. So this is the TR1 transformer. It is a 10-to-1 step-up ratio, I believe. And then that's going straight from the ribbon element into the transformer, stepping up, and then it goes into our active circuit, which just does a gain boost. It doesn't do any signal processing. It doesn't have any EQ to it or anything like that.
And it's really wild that it's a ribbon microphone that requires phantom power.
Yeah, that's it. So traditional ribbon microphones could be damaged by phantom power because if you ran phantom across that, kind of really thin element, you could burn it out.
You get that nice smoke smell.
Exactly, yeah. When you let the magic smoke out of a microphone, it just doesn't work
magic
anymore.
Smoke, exactly.
Yeah. So we keep the magic smoke in by having an active circuit so that you can phantom power it. That way you're getting a more robust signal as well. So our ribbon takes 48 volt phantom power. It'll give you an output very similar to a condenser mic. So rather than needing a dedicated ribbon pre,
it's loud.
It's super
really
loud. So and really clean. And the nice thing about having such low noise is that you can actually EQ the top end, because every ribbon microphone, just due to the nature of the actual element, has a kind of more rolled off sound in the top.
Yeah.
And you can actually EQ our ribbon without just bringing up the noise floor in those frequencies where the noise usually lives. So
and you get that awesome, rich ribbon microphone sound.
Yeah, and one of the key aspects of that is a really nice transformer. So
beautiful.
Yeah, making them ourselves means that we can make them really highly spec'd at the right price, and we can bring out a microphone that's incredibly well priced for the performance of it.
Yeah, awesome.
Yeah, cool. Let's keep going.
Okay, doke. So where are we now? More big machines.
Oh yes. So this is one of two surface mount electronic lines.
What is that?
So we manufacture, as much as possible, we do surface mount components on our microphones. Surface mount means that when you've got resistors, capacitors, all the different components that make up the electronics of a microphone, we have them surface mounted on a circuit board, which we'll see just in a minute. The idea there is that when you have the components really close together, you can actually make sure that they stay very quiet, the microphone. So you obviously want as little self-noise as possible. And especially these days when you've got so much RF flying around every space that you wouldn't have had, 50 years ago. You didn't have 2.4 gig flying around from everybody's wireless devices, iPhones, digital TV. So these days it's very important to have a circuit very close together and really well shielded. And we can do that with surface mount electronics. So in-house here we manufacture what is actually the quietest studio condenser mic in the world, which is the NT1. It's got only 4.5 dBA of self-noise.
Crazy.
Which is it is really, really low.
Wow.
So, typically you'd find at least 10 dBA of self-noise in a condenser mic.
So why are you running around with film reels everywhere?
So this is basically the way that you'd load up a surface mount electronics line. Right behind you here, you'll see a storage tower for some of the more sensitive components, but they're all on reels. So these two towers here will basically keep the components at the right temperature and the right humidity. And this is kind of for more sensitive things that might get damaged by moisture, just to make sure that they stay pristine before they go onto the board of a microphone. Now, the reason they're on reels is because they'll go through an automated machine that'll be able to manufacture the boards regardless of how many people are in the room. So part of the success that we have at Rode is manufacturing a really nice product at the right price. And we can do that because you can have a single person running a surface mount line and manufacture over 1,000 microphone boards a day.
Wow.
Which is crazy.
Can we see one of those, how those things work?
Let's check it out. So basically what happens, I'll grab a blank here so we can have a look. So microphone board will start out like this. This is actually an NT1. So this is the microphone board.
Oh, this is the board in the one.
That is the quietest one. So this is just a blank board. You've got all your kind of trace lines through there that are joining up the components, but you see here all the kind of open contacts.
Sure.
So what happens is it gets loaded up. We'll put a whole stack of boards in here, maybe 50, and then they'll automatically run through this machine, which is like a screen printer that screen prints solder paste onto each one of these contacts here. So it's automated. It's just like they do when they screen print T-shirts. Except when the blank goes on there, it's just screen printing the solder paste onto the raw contacts.
So the ink is actually ICs in various little bits.
Well, not exactly. The ink is actually the metal, the solder that you would normally have to do, with a soldering iron and do it manually by hand. This does it all at once, and it's kind of like a gooey paste that the components will stick to in the next process.
Wow.
So then the board will come through automatically
Oh, yeah.
into this machine. And this is where you see all these reels of components. So you've got a bunch of different resistors, capacitors, all sorts of electronics
Look at that.
in these nice little neat packets so that they're always protected from moisture. And this machine will pick up all those components and just stick them down. And because of that solder paste, they actually stick to the board.
Wow.
And then what happens is they keep moving through and they'll go
love
into the next machine.
I love that Rode Microphones actually uses film reels to put stuff on
Exactly.
their microphones. I mean, that's exactly what this is.
Yeah,
It's a film
you
reel.
got to live the life.
Live the life. That's awesome.
So then onwards here, we're going to this big pizza oven looking thing. Which
Technical
will,
term.
Exactly.
Yeah.
So it's basically what is going to flow the solder and turn that into a real connection rather than just a solder paste that's kind of
Sure.
a wet paste. It's going to gently heat up the components as they go through the machine, and we always make sure that you have to keep the temperature of this line below the kind of failure point of the weakest component. It's kind of like, the weakest link in the
Otherwise
chain.
it melts or something
Otherwise
horrible.
it melts, something will go wrong, maybe it goes out of spec by 2%.
Right.
Anything like that we want to avoid, so you have a specification for every component and you have to make sure that you don't overheat the weakest component. So that'll determine how quick we can run this machine here.
I see.
And then once that solder's melted, we've got, depending on the product that we're doing, we'll have a certain amount of boards on one kind of board here, and then we'll kind of snap them all out, we'll test them all, make sure that they have the actual right, kind of voltages running through the board before it goes on to the next stage where it'll get paired up with a microphone body, a capsule, all the rest of it and become a microphone.
Do you have these coming out the other end, or we're not running them right now?
We're not running right now, the line's actually cooling down, but we can see some on the
All
other
right,
side that
let's
we've
see
made
what that looks like.
throughout the day.
More cool reels. Oh, yeah.
So, I mean, you can see here what we've done. This is some stuff for the last few days.
Wow.
Earlier today, looks like they were making perhaps podcasters in this line. And basically what's happened is a production line has been running and it's finished. And you can see here this component board is fully loaded. So earlier today, that would have been stacked up. As the boards come in, it just
Coming
shifts
in
down
there.
automatically. And once it finishes, somebody will get a notification, okay, this run's done. Come in and switch it over to the next product or put more product in there.
So how much of this was done today?
So we can do around 1,500 individual boards in a day, and each of these has about 6 or 8
Yeah.
on them, depending on the product. So
Wow.
today, it's hard to say exactly which out of these were done today, but this would have been from at least the last 3-4 days to be able to get all of these boards running. Again, if we find that exact same microphone that we were doing before, let's see if we've got any to hand. Here we go. So this is the final product of that same
Right.
board that we saw. So as those kind of little arms are placing the components, these are the
Yeah.
components that they're placing down, then it got melted through the machine there, and then you have the finished board.
Wow.
And then that'll get tested just outside here to make sure that it's all up to spec.
And there's somebody hand testing those.
So these go into, it's like they call it a bed of nails, and you can see all these open contacts here.
Yeah.
These are all test points. So what happens is we put that in to a certain template that's set up for this particular microphone, and it'll run a signal through every board, and then it'll actually just throw up on screen which boards are out of spec, and we just put a cross on them, and we don't use them. We don't try to repair
Don't try to fix
individual
them.
components.
You're done.
We're done with it. We just take it out of the line because we don't want to obviously have anything go out that's not
Right.
perfect. So
Sure.
yeah,
Wow. Fantastic.
one of
So
the
we
things,
make the boards, and these things all get stamped, basically.
Yeah.
And then what happens?
All right, so then after the testing, these boards will get married up with a capsule. So we may as well go over and have a look at how the capsules are made.
perfect.
Yeah.
Perfect.
This particular machine here will solder all of the through-hole components. So some of the components that are too big to be able to be placed by that particular line in there with the surface mount, things like heat sinks for power supplies or for
Yeah.
amps. Like you can see here, these are all very loosely placed. So
Oh,
I can't
yeah,
pick them
big
up.
heat sinks.
But big things like that, larger capacitors that need to be a larger part. Where we can, we surface mount, but some parts just have to be a larger part, a heatsink, things like that go through hole. And that'll go through this particular line here. In the same kind of process, it does a whole bunch at once. They'll go through and get heated up by these lamps all the way along, and then there's a big flow of liquid solder that goes underneath the bottom of the board.
Like a big waterfall of solder.
Exactly, yeah. And then what happens is that'll actually attach itself to all of the component contact points at the bottom without actually sticking to the board, because the board's got like a coating that stops any of that from making bridges. And then you've got, in one go, you've got a perfectly soldered board versus having an individual kind of
Sure.
do manual labor
Sitting there
of
forever
soldering
doing
each
that.
one, where you have a higher chance of getting, kind of dry solder joints and all that kind of thing.
And you have the same thing here where you're only going to heat this up to the temperature of that
Exactly.
weakest or lowest melting point component.
Exactly right, yeah. So the minimum temperature that we can get the actual solder to stick to the components, basically.
Right.
We can actually go a little bit higher in some ways with these because it's actually heating up underneath rather than being a direct radiant heat on top of the component itself.
Wow.
But there's a lot more hand labour in this kind of process, as you can imagine, because somebody's had to place every one of these components in the correct orientation and everything like that.
And what are these like for? What does this go to?
So this here is a power supply for a valve mic, like a NTK or a K2.
NTK?
Yep. So that's what you're seeing here. Over here, you'll see perhaps a podcaster. Does it say? Yeah. So this is the podcaster, which is a USB mic.
Yeah.
So there's a lot of little bits like the rotary knobs for the volume control, things like that
Sure.
that we have on there. Yeah. So that's the kind of thing that you'll see, but there's less and less product in there each year.
Fantastic.
Yeah,
Little road spears.
Yeah, yeah. So that's the Micro Boom Pole Pro.
Sure.
It's a carbon fiber boom pole, and when you've got all three pieces stuck together, it's only 125 grams.
Yeah, it's
so
really
you
light.
literally hold it with a couple of fingers.
It's beautiful.
The idea there is that whether you're trying to get into a really tight space, like a small interior shot or something, or if you're a single shooter and you're just trying to get your microphone closer, which we obviously always recommend to people.
Always.
That's the perfect product to be able to do that.
Awesome.
Especially with those lightweight microphones.
Yeah.
So, yeah. Cool. All right, so this room here is the diaphragm manufacturing room. Now, when you've got a condenser microphone, you've got the backplate and the diaphragm, which work together as like a capacitor to actually generate an audio signal. The diaphragm itself has to be kind of elastic. It has to be able to vibrate to the sound in air, and that's what's actually going to generate that electronic signal. So what we do in this room is actually manufacture those diaphragms for the true condenser microphones that require an external biasing voltage.
NTG3, NTG8.
Yeah, exactly. The vocal microphones like the NT1, NT1A, K2, NTK, all of those large diaphragm mics, the NT series, so the NT5, NT6, NT4, they're all manufactured in this room.
Wow.
And the way that we do that is by getting some gold spattered mylar on a big sheet.
Gold spattered mylar.
Yeah, so mylar is like a kind of, it's almost like cling wrap
Sure.
kind of material, but it's really strong and you can stretch it out really taut, and that's what's actually going to vibrate with the sound. And that's actually coated with like a pure gold.
Is that
kind
what
of
this stuff
plating.
is?
That's what that stuff is there, yeah, exactly right. So it's
Wow.
really thin. I'll get a bit of the stuff that we've actually manufactured.
It's like a candy wrapper almost,
Yeah.
but a little bit more resilient.
Much
Wow.
larger sheet. So this is one that didn't quite make it. It might have popped off while they were. Oh, there you go. There's a bit of an
Little hole.
imperfection in it.
Yeah.
So basically, what happens is I could actually do. It's a much more scientific process than this, but just to show you the basics of how it would work, you basically stretch across the mylar like this. On a jig, which has a tensioning rig that'll go down on there and tension that mylar to a specified kind of tension. And then we'll place a bunch of capsule rings around that mylar.
Yeah, you can kind of see where it was once.
Yeah, exactly right. So we'll place a bunch of capsule rings, and then that'll hike up that tension frequency, the resonant frequency, into a much higher frequency. So you can imagine if the resonance is kind of under 1,000 hertz here, it's going to be much higher once you put a smaller ring on there.
Sure.
And that resonance is actually what you'll see on a response chart. You'll often see like a little presence boost on a especially like a 1-inch diaphragm microphone. That's actually tuned at this kind of stage where you get that tension right so that it has a resonant frequency in an area that you want to boost the presence of the microphone.
Oh, I see.
Yeah.
And so actually changing that tension radically changes
Absolutely.
the frequency response of the microphone.
Yeah, so you've got that aspect of it. You've also got the porting on the back of a capsule where the holes are. The venting of the capsule is going to make a big, kind of change to the sound of a capsule. But this is one of the key parts of that.
Same with the speaker. You basically design it around that port, that hole.
Yeah. Yeah, exactly right. Yeah. So that's kind of what we do in this space. So we'll get the mylar to be stretched over. It's a kind of reel of mylar, which you can probably see just over there in the corner. There's like a nice kind of clean roll of it. That then gets tensioned to a certain resonance with a speaker. So you see the speaker just here.
Oh, yeah.
So what happens is these get placed above the speaker, and then we play a frequency, a preset frequency, through the actual diaphragm. the larger size of it, and then you'll actually just hear it vibrate in sympathy super loud as soon as you're on that right frequency.
Oh, wow.
Yeah.
Now, are they all, I mean, you've done tens of thousands of these. Do they all resonate kind of in the same frequency? When
Has
you
to be
know?
exact.
It has to be exactly right.
So what we do is we tension it to the correct frequency. There's actually a laser interferometer that'll measure these to make sure that they're at the right frequency.
A laser what?
Interferometer.
Interferometer.
Yeah, so we'll test them
Fantastic.
periodically to make sure that we've got everything perfect, which
Fantastic.
actually, it kind of measures the vibration of a surface.
Got it.
And then what we do is we lay out these capsules so that they can actually rest, because it's like a guitar string. When you stretch it, it's going to eventually kind of loosen a little bit, and then you have to tension it again. So we let them rest, and then we retension them 24 hours later, and then the actual capsule rings will get glued onto
These little guys here.
diaphragm. Yeah, so that's like a little screen printing jig for the capsules. This is the kind of brass ring. We've manufactured that in that same room that we just looked at,
Yeah.
out of a solid bar of brass.
Brass.
And then that ring will get glued on top, and that way the mylar's at the right tension on that ring, and then we bake it in an oven. So it's a glue that we have to, obviously this material, you can't heat it up, because what happens when you heat that up is it'll melt, it'll change, it's a very delicate material.
Sure.
So we get it to like just kind of like a warm temperature so that the moisture evaporates out of the glue that we use, and then that way we can very gently over 24 hours dry that glue in these little ovens just over here. And then what happens is you end up with, perfect example right here, you've got some capsules that are kind of, these look like ones that have been rejected at the moment. So the others have all gone through. So we'll place it into this jig to be dried, and then it'll go into this machine here, the next stage, which is laser cutting them out. Now, a lot of other manufacturers use a razor blade and just cut around the outside of it, and that's how you make a diaphragm. We like to do things with absolute precision, so we have a laser cutter that'll actually cut the edge, and it'll kind of melt off the edge and make sure that it's always perfect.
Perfect.
Yeah. And then basically that's how you have it. That's how you end up with a nice little diaphragm. And let's see if I can
Highly
find one.
precision-made diaphragm.
Absolutely. And then over here you can see, if I'm extremely careful, this
Wow, beautiful.
is the inside of a diaphragm. That's what's going to go against the back plate. And that's what the front looks like. That's what you're used to seeing when you're singing into a large diaphragm mic.
So this is like NTK size.
Yeah, NTK, NT1, it's a 1 inch,
Yeah.
1 inch diaphragm. That diaphragm will be common across a couple of different capsules, but this diaphragm will have a certain resonant frequency that might be in the NTK and the K2. And then we'll have a different capsule for, say, the NT1, which will have a different resonant frequency, and it'll go into a different backplate. But this is kind of where the art and the science of making microphones kind of joins together.
So for people who don't know, we've just gone through that that's basically a mylar pulled, extremely taut thing, and people don't understand how delicate microphones are, even just regular capsule microphones, to say nothing of ribbon microphones.
Yeah.
So, I mean, we could easily, if we were silly, put our fingers through that and it would go through.
If you even touched it, you
Yeah.
would potentially stretch it and it would stop working. I mean, to put it into context, right now this diaphragm's doing what it's going to do for the whole life of the product, which is vibrating in sympathy with the vibrations of the air. So it's so sensitive that it's actually moving right now. The only difference is it's not up against the backplate that's going to, act as the electronic capacitance
To create the
pick up
voltage.
to pick up the signal. So, but there you have it. That's a diaphragm. That's how it's made.
Man's best version of an eardrum. So when did Rode make its first microphone, and how did it come about?
So the first mic was made in around 1992.
Wow.
And basically at that time, microphones, for a decent microphone, it was really expensive. You're talking a few $1,000s.
I know. I remember.
Yeah. So Rhodes' kind of founder, Peter Friedman, that's kind of when he started the company. Before that, it was his father's company, and they used to make electronics. They used to run, PA systems. They manufactured some of their own PA systems. And he had this microphone, which had a really nice capsule in it, but really poor electronics. And he kind of pulled apart the microphone and fiddled around with it and made this really nice sounding microphone. And went, hang on a second, this could really sell. And at the time he thought, if he could sell 500 microphones, he'd be set. I mean, to put it in context, this year we're on track to ship 1 million microphones.
What?
So yeah,
Wow.
it's a pretty crazy kind of growth from there. But that was the start of Rode. The first microphone was actually the NT2, and we had the NT2 and the NT1 we launched. And those kind of carried on for years, and now, from those two microphones, we've now got, in the the microphone kind of range. There's more than 45 different products.
Yeah.
Starting out from the first two. And
And
these
then a
days,
whole line of ancillary products as well.
oh, absolutely, over 100 accessories, yeah.
Sure.
And these days, I mean, you can see it's all manufactured in Australia, everything from diaphragms to bodies of the microphones to the electronics.
Is it all here?
Yeah, it's all here. There's a couple of bits and pieces that we order in, like plastics, but as of this year, we're actually manufacturing our own plastics as well. So everything from shock mounts to kind of stand mounts, the little bits and pieces, the whole capsules, we can actually do that all in-house, and we'll see that in just a minute, the actual plastic assembly line. So,
Awesome.
Yeah.
So what's this place? It's it says no cameras, and we're here with a camera.
Yeah, we're always kind of breaking the rules here, but this is it's not in action at the moment, but this is the capsule assembly space. So when we've got our back plates and we've got our diaphragms that we just saw there, it has to be a clean space. Everyone has to wear gloves, hair nets, shoe nets,
Wow, okay.
And this room here is a positive pressure chamber, which means that it's got higher air pressure inside than outside. So air's always flowing outwards and you don't have dust kind of floating in.
Right.
So it's a very clean space. There's, kind of a glued floor so that when you walk in, it takes all the stuff off your shoes and everything like that.
Whoa.
And these little pods that you see in there are where the different components of a microphone capsule are married together.
And they're done by hand.
Yeah, so that's done by hand, and then there's certain tools that get them to a particular torque for each screw. Each of those kind of stations there has like a big vacuum behind them that sucks all the air out. So if there's any dust floating around, it goes straight out and doesn't end up in the microphone. You can imagine with like a sealed microphone, like an Omni capsule,
Sure.
the last thing you want is a tiny, even small little piece of dust inside between the backplate and the diaphragm, because it's going to affect the response of the mic. So the way we combat that is by having a positive pressure chamber with HEPA filtering on the input.
And is this the only clean room like this that we have here?
Not exactly. I mean, all of the spaces that we run, this is the only clean room to this level where we've got the positive pressure. So it's the only positive pressure chamber. But if you see throughout the factory, like for instance in the surface mount line that we just saw there, as you walk through, you walk on like a sticky floor that kind of takes any of the dust off your shoes. The temperature of those rooms is controlled in a different way to some of the other areas that are less sensitive. The paint line has a giant oven in the same space as a whole bunch of air conditioners to keep it at the right temperature. Wow. It's like a big push-pull kind of balance that we have to follow. So
you're saying you're shipping 1 million microphones, you're on track. Have they all gone through this room?
Just about, yeah. So there are some capsules that aren't manufactured in this room, some of the electric capsules, but just about every single true condenser microphone, absolutely, because this is where we manufacture the true condenser capsules. That's where they're put together. So yeah, I mean it's a lot of microphones go through that one little space there, including the ribbon elements as well, the NTR ribbon elements.
Wow.
So yeah, it's
this very sacred space.
Yeah, it is. Yeah,
where microphones are born.
Yeah. It's probably going to have to grow a lot bigger before too long, But, yeah. Cool. Let's move on to the next stage. All right, so what we see here is the backplate, the raw part of a backplate of a microphone. So these parts here, the kind of raw brass piece, this has been manufactured in that first room that we had a look at where the bodies of the microphones are made.
Sure.
So it's machined out of a solid piece of brass.
Yeah, that is brass, all right.
Yeah.
Beautiful.
And then what we're doing here is we're actually injection molding plastic around the outside of that capsule. Now, the way that, as we've already explained, the way that a diaphragm works is you've got that diaphragm at the front, you've got the back plate, and you have to separate those but have them very close together to actually, make the diaphragm do its thing. That gasket is generally placed on top of a backplate. Usually when you see a condenser mic, you've got the backplate, then a kind of gasket, and then the diaphragm. You can imagine how much inconsistency there'd be with a gasket because it can get bent as you put it on,
and
different
heat
thicknesses.
Changes it.
Absolutely. So the way that we do it is with a super high resistance plastic that's actually molded around the backplate. And then what we'll do from here is actually machine the metal down so that it's got the perfect gasket thickness every single time.
Wow, great.
So this machine here is actually the same kind of machine that they use to manufacture Lego, which is kind of funny.
That's great. So it's a giant plastic Lego machine that makes precision moldings.
Exactly. And if you think about Lego, you can pick up a piece today and a piece that was made 30 years ago bang, they'll click together. It's some of the most high precision plastics out there. And that's why we're using the same machine to manufacture precision microphones.
Fantastic.
Yeah.
It's your NTG4 Plus end cap.
Good eyes.
For sure. Well, it kind of says so.
Oh, right there. Okay.
But
yeah,
I do
thought
know-
you were just picking it out.
No, but I do. Yeah, it's pretty awesome.
You got the heads of NT5s here.
Yeah.
Even the end caps for Micron connectors.
Yep.
We manufacture it all here, so a bit crazy. What else we got sitting around here?
There's your top ring for your NTG3. Brilliant.
Top rings for NT5s, so that'll go in the very top
Yeah.
of the microphone. But yeah, all sorts here. But the really cool thing in this space is this little line here where we've got robotic arms that basically take that raw piece that we looked at just then, which is the brass with the plastic around the outside, and turns it into this. And this is what a finished backplate looks like.
Wow.
Now, this one's been rejected. There might have been an issue as it went through the machine, but it's a very high precision machine that'll get the top of this backplate to within 1 micron of flatness and twist. It's super, super high precision.
Micron.
1
Million.
micron. Yeah, straight up. So basically the idea with a backplate of a capsule, if you've got inconsistencies on the backplate, that's where you'll test out a bunch of capsules and they'll all have a slightly different response. You know, you've got a different tension, you've got a different, kind of height of the backplate. That's where you get inconsistencies. But with this machine here, this is the same kind of machine that they use for the manufacture of watches, for instance, like really, really small, really high precision parts. And we use that to make the backplates because we know that we're going to get absolute consistency every single time. I mean, this one here, just rubbing your finger over the top will spoil the finish.
Oh, wow. It's that fine.
Backplate, yeah, absolutely.
Wow, that is so fine. You're right.
Yeah. I mean, you can see the difference between something that's been machined on a regular kind of machine. You
Yeah.
can see the roughness compared to what you end up with there. And drilling those, tiny little holes, it's so precision.
Yeah, you can see actually your fingerprints are
Yeah.
scouring it.
Yeah, exactly right. So
Wow.
having that gasket machined, if you can kind of look on the right angle, you can see the gap here that's been placed around the outside, and then that actual high resistance plastic is sitting just a little bit higher, and that's what that diaphragm is going to be screwed to, and that's how you get a really high precision full diaphragm assembly.
Wow.
So yeah, that's how it's done.
Fantastic.
Cool. So what we got here are some other components that have come from our machine shop. You'll be familiar with this line tube here. This is the line tube for an NTG8.
Wow, yeah.
Feel how light that is. It's made out of aluminium, so it's super lightweight.
Super fine.
Yeah, and obviously when you've got a long microphone like that, at the end of a 3-meter boom pole,
I know, I've held it.
things are going to get heavy quick,
Yeah.
so you want everything to be as light as possible. But right next to that, you can see a whole bunch of plastic injection molding tools. So we have our own tool making workshop, and tool making refers to the actual molds that make the plastic. Now, a tool for a plastic part can cost upwards of $400,000-$500,000.
Yeah.
They can get very expensive, and that tool will last the whole life cycle of a product. You make a million products through that particular tool. But what we started doing recently is getting our own tool making team in so that we can do everything in house. Everything from the mold that will be used in the injection molding machine to the metal work and everything. We can do it all in house, and we can keep absolute control of that. And it means that we can be really quick. If we want to make a little adjustment to a clip or something like that, we can do it straight away because we've got our own tool making workshop. So.
Wow.
And these things are super, super, super heavy. Each one of these is kind of half.
I was going to say,
side.
it's got to be really expensive and really heavy.
Yeah, exactly right. So I mean, this is that's a half and that's a half. So you need a kind of a full big engine hoist kind of thing to be able to move them around.
Right.
So yeah,
Brilliant.
cool. Let's check out the paint line upstairs.
Yeah.
So right here, you can see some of the environmental testing that we do at Rode. So apart from actually getting products in the hands of users, letting them try them out, as you probably know, we've got a 10-year warranty on a lot of our mics.
Right.
That's a pretty big commitment as a
That's a
manufacturer.
large commitment.
Yeah. So what we want to do is make sure that our mics are going to stack up to all sorts of different environments, even stand the test of time, just in studios, getting chucked around, all sorts of stuff.
So that there's condensation on the inside of this, that means what?
So this is a temperature and humidity programmable chamber. So what this is actually doing is making it super humid, then super dry, then super humid, and it's kind of simulating the effect of an environment over 10 years in the space of maybe a month.
So are you putting an NTG4 in here?
Absolutely. We'll put
Wow.
every product that we manufacture, we'll go through a environmental testing. And
Even
every
though-
time we have a new revision of the product, it'll go through testing.
So every revision of even the electrets go into something that's super humid, and
Absolutely,
it
yeah.
still works after that.
Yeah, well, perhaps not, and then we'll work on improving the microphone, you know what I
Wow.
mean? So before we release a product, we want to make sure that it's going to stack up to a certain amount
Sure.
of punishment. That happens with this super low-tech looking machine as well, which is a
With the
salt
nice rust
spray
on it.
tester. So this will kind of just spray out really, really salty water and try to corrode
yeah.
the microphone bodies so we can test the paint surfaces, things like that. We've also got vibration generators, which is like a big vibrating table that you place the mic on to test out the clips, the mic clips, shock mounts, see what
Oh
we're
yeah,
going to do.
the stress of them.
Yeah.
So
I
this
mean-
is sort of microphone hell here.
Yeah, this is where we try to break them and see how,
Wow,
see how
this is
that works
great.
out. But through this room here is actually the paint line. And we don't paint our microphones, we ceramic coat them. So one of the big things that you see when you purchase a microphone that's painted, whether it's black or red or whatever color, it's actually just a painted microphone. Whereas what we do is we actually ceramic coat the microphone and bake it in an oven. And that means that you've got a really, really hard wearing finish. And 20 years down the track, it's still going to be the same color and it's not going to be all scratched up from
Yeah.
going in and out of shock mounts. and
All my
whatever
Rode
else.
microphones look pretty much like they did the day I got them.
Absolutely. And the idea with the ceramic finish is that it has a really low sheen. It's got a nice kind of finish, a real satin finish, but it doesn't kind of polish up over time and get shiny. And obviously with an on-camera microphone, you know, if you're shooting somewhere where you might have a reflection or something, the last thing
got
you
a
want is a
problem.
bright, you know, kind of shotgun mic sitting just out of frame or something like that, especially for the Pro Series mics that are going to be right near the edge of a frame.
That's right.
You want it to not shine and sparkle. So having that ceramic finish makes sure that it stays, you know, out of sight.
So how awesome is it to have a microphone manufacturer that's thinking about the filmmaker and the film process, right?
Exactly.
That's great.
Well, the thing is, you know, we make a lot of videos in-house. So, like educational videos are a big part of our strategy. We want people to know why they need to use a shotgun mic, not just, you know, to pick up one. We want to show people, how do you use a shotgun mic? Why do you want to use it? And because we're using them every single day, you know, we need to make sure that they work for us as well. So
Sure.
it's one of those things. You know, we have filmmakers in-house, we've got a team, and they're, you know, a big part of the development process. What do you guys want? You know, what do they want to see? And then that's what we kind of all get together as this big kind of collective and talk about new products and all the different implications, and that's how we end up with, you know, every single product that we have. So,
Perfect.
yeah, let's check out the paint line. So it's pretty loud in here, but this space is our paint line. This big rack that you see here that's holding all the different microphones.
Yeah.
Yes, these are pie tins. It's the easiest way to stop any runoff. This is quite a new microphone. This is a Video Micro that we saw down in the machine shop.
Sure.
And basically we place the microphones on this big rack that's negatively charged. It's got a negative charge, and as the paint comes out of the nozzle, it gets a positive charge of 10,000 volts. And what that means is that the paint sticks to the microphone. It's
Wow.
attracted to the microphone. This is all metal.
That comes through here.
Yeah. So this has got a negative charge, the paint gets a positive charge, and it's just attracted to it. It means that
way.
we can get a perfect coating on the microphone, and we have way less wastage of paint because the paint wants to stick to it and wants to coat it properly.
Wow.
So we could probably squeeze in and just see the paint process as it goes. So if you want to follow me through this treacherous little
We're following.
area. So you can see here, this is the nozzle, this is the paint head, and that'll just kind of go all the way up and then it'll start spraying paint through. And these parts will start wobbling and spinning, and that means that we'll get a perfect coating on them. So that kind of action of spinning around the whole thing as
Is
well
that
as
happening right
internally.
there, right now?
Yeah, so that you can see those ones have just been done. It looks like the guys are maybe refilling the paint or changing something up at the moment. But there's a big water wall that goes behind. It's like a waterfall that catches any of the paint runoff so that the environment in here stays healthy.
Yeah.
But what's happening there is these microphones going through, that charged paint will go through, stick to the mic, and then they'll head all the way around and bake in the oven, which we can check out.
Beautiful.
Yeah.
Very confined spaces.
And I mean, it's quite a comfortable temperature in here right now.
Yeah.
But consider that that is a giant oven, and we have to keep it all in a controlled space. So what we have to do is kind of heat the room and cool the room at the same time to keep it at the right level.
Yeah.
When you feel the heat coming out of that, the microphones that are coming out of here are very hot, so you wouldn't want to actually touch them. But you
Yeah.
can see right here at the edge, there's some finished microphones
Yes.
that have been ceramic coated, and they go in like this. You can see that's a blasted body. You see how it's got nice surface area?
Yeah.
all of these are kind of varying levels. They get kind of roughed up a little bit before they go in, and that's just so it's got more surface area and more adhesion of the paint.
Attached to.
Yeah.
Brilliant.
So that's how we paint the microphone bodies. Everything from the NTG3 Black, the smaller video micros, NTG4,
Right.
The NT1. They're all ceramic coated, not painted.
Beautiful.
Crazy, huh?
That's a great process. And it's environmentally happy because you're reusing paint that's running off
Absolutely,
and all
yeah.
of that.
I mean, everything that we do, we minimize wastage. Even as the microphones are manufactured, you would have seen all that swarf laying in front.
Yeah.
That gets sent back to the guys that we buy the bars from. They melt it down, they sell
Make
it
it
back
into
to
the
us. So, it's always running through, and there's no, kind of needless wastage in the process.
Brilliant.
Yeah.
Great
Cool.
stuff.
Let's go check out the next stage after
All right.
they've been coated.
Yeah.
Cool, huh? Now you can see here, this is the mic that's just come out of the paint line. That's the NT1.
Yep.
Quietest studio condenser mic in the world.
Fantastic.
Some of the smaller ones, like the video micro body, that's before it gets the attachment that'll help you place it onto a smartphone.
Perfect.
The shotgun mics, you can see here in the rack, this is the NTG4 Plus.
That's the 4 Plus, a little bit
Yeah.
longer. There's
And
your
I mean,
button
feel
noise.
how light that is.
Wow.
It's insane, right?
It's like not even an ounce, maybe
Yeah.
in the ounce range.
So, I mean, we want to make these as light as possible so that, when poor guys like us have to hang on to the boom pole
I
for
know.
2 hours during an interview that runs over time.
Yeah.
And you can see here as well some of the screen printing of the Rode logo and the product name has been done in here as well. So that's where
Now,
the
is that
microphone
done the
starts
same
to-
way with or is that screen
No,
that's screen printed?
So
Yeah.
it's not running right now, but this is a screen printing machine. The way that it works is that, this is a pad printing machine, excuse me. So basically, these pads here will pick up the print, which will be either the Rode logo or a product name, and it'll then stamp it onto the body of a mic. And the good thing about these being like a silicon kind of is that they form to the shape of the body, and that's how you get a perfectly printed logo or really fine detail on the name of a product, even though it's a rounded shape.
Right. That was always a quandary to me. How did you get printing on a round?
Yeah. So you just kind of pick it up with something that's really flexible, and then it places it down
push it on
perfectly.
it.
So yeah,
Brilliant.
cool. All right. So this section here is where we laser etch the serial numbers,
Oh yeah.
product names on our microphones. So you can see here, this is a NT1A, and the name of the mic, Rode NT1A, the serial number, and the whole Made in Australia tag there.
And it's burned on here.
It's burned on, it's never coming off.
Right.
So it's etched right into the body of the microphone. That's the important thing because people can register their warranty online, and 10 years down the track, if that's just a sticker, it might peel off.
Right.
And we want to be able to trace any problem that we have with a microphone back to the original manufacturing date and go, okay, is there something we could have improved or whatever? We're constantly trying to improve the products. And the warranty system, when people register their warranty, and then if anything goes wrong, even if they drop it and it breaks, and we go, okay, well maybe we can change this aspect of it or the shock mounting or something. But the good news is we have way less than 1% returns on our products.
Wow.
Which is a very, very low failure rate. And that's a testament to all the testing that we do in-house.
And that you do it all in-house as well.
Exactly right, yeah. I mean, we don't deal with external suppliers that might just try to push things through, which might happen in other contexts. But here at Rode, because we do everything in-house, we've got complete control. We can make sure that everything goes out up to spec.
Brilliant.
But these machines here are kind of cool. They're not running right now because the factory is kind of closing up for the day. But you can see here these different kind of caddies there to hold the mics. And within a couple of seconds, a super high-powered laser will actually laser etch all of that information onto the microphone.
Wow.
See here.
How long does it take to etch them?
Oh, geez, probably about less than 10 seconds. I'd say between 5 and 10 seconds.
So they're just turning pretty quickly.
Yeah, they turn. It's super fast, and you can just see the smoke coming off it, and everything is crazy.
Wow.
But you can see here, this is a before etched and after. Mm-hmm. So it's got the gold dot on there, but this one's still blank, and then you can see, once it's done. So.
This one's waiting for its warranty.
Yeah, exactly right. Yeah.
What's the biggest killer of microphones?
Yeah, so the biggest killer of microphones is moisture. So any microphone basically operates with a very, very small gap that the electricity is passing through to generate the audio. You've got sensitive components in there. You can see all the control that we have in-house to make sure that moisture doesn't get into the microphones here. But when they go out in the field into really, kind of humid environments, they get wet, they get rained on, and then they just get chucked in a bag without being dried off or left out to actually dry properly. That's when microphones go wrong.
And that's why you have those. Rode has the tubes that are super watertight.
Yeah, and we also ship every microphone with a little absorbent pack, a little silica gel absorbent pack. The best way to store your microphone is to place it back in a bag with the absorbent pack, and you know that it's always going to be fine.
Right.
It's still, they're quite resilient, but if there is something that's going to damage a mic, other than dropping it, it's going to be moisture. So if you're in a really humid environment, it's a really good idea to protect your mic from humidity. And if you happen to have a shotgun mic on your camera, it gets a little bit of rain on it, just pull the foam off and make sure that that dries separately from the microphone, and you'll make sure that your microphone lasts forever.
So here's a question. I'm using an NTG3. I have it on a boom pole. The scene's outside and it's below freezing. And the actors want to walk into a 20-degree room inside. What's going to happen? What's my problems?
Okay, so when you're freezing cold outside and then you go into a warm room that's probably got a bit of humidity because there's people in it, what will happen is condensation on the outside of the microphone. Now, when you've got a foam windshield on there, usually your mic's pretty well protected because the moisture is not going to get through that windshield into the sensitive components. But if you haven't got a windshield on, or if you've just placed the microphone inside, you get condensation on the mic. Anytime you've got, cold metal or glass or any shiny surface that's really cold in a humid environment, it's going to condense the air. That's just what
so we don't have to worry about water inside the microphone condensing if we have that
if
shield
you've got the foam windshield on there. But what you will have to do is make sure that once the microphone's at the same temperature of the room, make sure that they do dry out before you put them away. But one consideration, if you are in a very cold environment, you come inside and you do happen to get a little bit of condensation in the microphone from the small amount of air that gets in there, an NTG3 or an NTG8 is actually really resilient because they've got RF bias. So rather than a voltage bias going across the diaphragm and the back plate, it's got an RF bias, and with a voltage bias capsule, what happens is if small amounts of moisture get on the capsule, it shorts out the microphone, and basically you've got no audio.
You're done now.
Yeah, or it'll crackle right as you get loud sounds.
So with an NTG1, a 2, a 4.
Yep, or just about any other microphone that doesn't have RF bias, which is the majority of all microphones that you'll see in the world.
Sure.
They're more susceptible to be shorted out by moisture than an RF bias microphone, because that RF bias has a different resistance, and basically it's easier for the signal to continue coming through clean than it is to jump across that circuit and short out the microphone.
Sure.
So you end up with a really resilient mic. So if you are shooting in extremely cold temperatures, and we're talking extremes here, you're in
like what?
Really humid environments, like if you're shooting in a Bikram yoga studio, or if you're out in the Antarctic or something, in these really extreme temperatures, you absolutely should be buying an RF bias microphone because you know it's going to keep working. And especially if you're going hiking somewhere in the snow, the last thing you want to do is get to halfway through your trip and your microphone stops working. Whereas with an RF bias mic, it's going to sustain the craziest temperatures and it'll keep working.
Fabulous.
So, yeah. Cool.
Good stuff.
So let's check out the valve mic testing areas. So the first little machine you see here, which is pretty cool, is full of little valves here. These are Electro-Harmonix valves. They're really nice valves. And basically what we do is with a couple of our microphones, we use a valve that processes the audio signal. The audio will run through a valve, which gives it this nice kind of even order harmonic distortion, which sounds really pleasing to humans. When you've got, kind of odd order harmonic distortion like you do with a solid state circuit, that's when it sounds really nasty when you get that kind of distortion, even the smallest amounts. Whereas when you add a little bit of even order distortion, it sounds really pleasing. It sounds warm. It's the sound of, old school music that you've been listening to your whole life. And
analog tape, LP
kind of
versus CD, that whole argument.
Exactly.
Right.
So a couple of our mics, the NTK and the K2, and the recently discontinued Classic 2, have valves in them. But one of the things with valves is that they can be quite sensitive. And what we do to combat that is we burn them in for 24 hours. We make sure that we let them run. They get up to operating temperature and cool down and get back up to operating temperature, and then we test them. and any that don't pass the test, which, when you buy a good quality valve like this, usually they're all fine, but we still test them to make sure they don't end up in a microphone if they're not up to spec.
So valves typically, valves are typically moody.
They are.
So how did you get over that?
So generally, if a valve is going to fail, it'll be very early in its life. It'll be, within the first couple of times of using it, heating it up, cooling it down, heating it up. These guys will actually test the valve before shipping it out.
Perfect.
A lot of manufacturers that are, respectable manufacturers will, but just to be absolutely certain, we like to test them in-house ourselves, and that way we can make sure that every single road mic that goes out the door isn't going to have a valve in there that's making a bit of noise or anything like that.
All right.
If it passes the test in-house here, it's basically guaranteed to work absolutely fine for years to come. But valves are a consumable part, depending on the amount of hours the microphones run. Eventually, you'll hear a little bit of a difference. You might want to change your valve, but to make sure that you don't have to do that too soon, we actually throw them in.
Yes, and if that happens, what are we talking? 5 years, 10 years, 15 years?
Look, it depends. I mean, if you've got a studio that's running, the same mic, kind of 8 hours a day or something like that, you might get 10 years out of a valve before you replace it.
So we're talking a long time for reasonable use.
Yeah, absolutely. But at the same time, valves are moody. You might only get 2 years. It's a little bit of a tricky thing to classify. But
the NTK and all the valve mics are 10-year warranty. We send it back. And then we get it back.
Yeah, that's why we offer a warranty on our mics, because we want people to have peace of mind that when they buy a mic from Rode, it's going to work. Yeah. It's going to do exactly what it does on day one, at day 10,000. So,
right.
The benefit though, with having a valve and getting that kind of harmonic distortion and everything only kicks in after you've warmed up the mic. So that's another thing that you have to think about when you're.
So how long does it have to be on before you get that nice feel?
I generally recommend about 7 minutes.
7 minutes?
Yeah.
Wow.
Yeah.
Okay.
So you never want to just turn on your mic and start recording, because the sound, you'll actually hear it. If you turn on your valve mic and start talking into it, you'll actually hear it the sound develop. It'll just get richer. And then all of a sudden, when the valve gets up to operating temperature, it no longer changes. The sound won't change anymore. It happens within about 3 to 4 minutes, but to be absolutely certain, you want to kind of double that. You want to go 7, 8 minutes.
Wow, that's brilliant information right there.
Yeah, there's some misconceptions out there. Some people warm up their mics for half an hour, and they're just wasting their time after a certain amount of time. I'd hate to have my vocalist waiting for half an hour every time. But, if you're set your mic up first, turn it on, and then get your channel strip set up and everything, and by then you're ready to record. But to get the best sound out of your valve mic, make sure it's nice and hot, because that's where it's actually going to be doing the best work.
Anything else we can look at?
Yeah, sure. So right here, once the valves are placed into a microphone, they're paired up with a power supply.
Look at this.
And then we run the mic and the power supply at the same time, because this power supply is powering up the valve in the mic.
Perfect.
We want to make sure that the power supplies are burned in. You can see, they're valve mics here. So we'll place them all on the rack, we'll turn them on, they'll run for 24 hours, and then they'll actually be checked the next day. So these have obviously already been tested, or they will be tested tomorrow, because the rack's not running right now.
And you test them at 2 different voltages?
So it depends which market they're made for. So in Australia, we're running 240 volt. In Europe, they're running the same. In the US, you're running 100 volt or 120 volt. 110, there you go. So we have to, depending on what market they've been manufactured for, we'll test it at that voltage and make sure that it's running fine.
Wow, great.
Yeah. And then from there, once we've got these microphones packaged up, they're laser etched, they've been tested, they run in, every single microphone gets listened to before it leaves. So even though it can pass all the tests, you might have a little rattle in the microphone because something hasn't been screwed in properly. It might pass all the electronic tests. So we'll pick up every mic, we'll shake it, we'll kind of talk into it 1, 2.
Some guy's sitting there with headphones on doing this all day?
Yeah, absolutely. Yeah.
Wow.
So we've got, in this room here, we'll have, 1 or 2 people it's quite a quick test. I'll just give it the subjective test, because it's passed all the electronic tests. We know that it's performing how it should, but does it sound right? Is there something that for some reason doesn't feel right about the microphone? Is there, as I said, like a little rattle? Is there something that, for whatever reason, hasn't been put together properly? And that way, you know that every single microphone that leaves has actually been listened to by somebody, and we can trace that back. We can make sure that everything has been tested properly.
Is it all microphones or just the 2 microphones?
No, every single microphone.
So 1 million microphones this year. Some actual living person is going to be shaking it, going, "Hi, I love you, baby. Come kiss me tonight." And oh yeah, that doesn't sound right here. You see.
yeah. So it's just go 1, 2, test, shake it around, cool, next one, move them down the line, and you will listen to every mic. I mean, these mics here have just been listened to. So
Wow, that's fantastic.
yeah. And then that way we make sure that not only are the electronics and then the capsules tested, they're put together, they then get a sweep through the mic to make sure that it's within a tolerance, and then they'll get listened to, and then they get packaged and they go out. So that's how you make a good microphone.
I get that.
Yeah.
So this is a crazy, crazy space. I mean, you can't tell from a camera, but you find out if you have ear ringing in your ears or not when you're in here, because it's this is an anechoic chamber. What is that?
So an anechoic chamber is designed to simulate what you call in the acoustics field a free field. So the sound comes out of a source and it doesn't come back. Now, anytime you're in an enclosed space, even if you're outside, what happens is you speak, the sound reflects off the floor, it hits the walls, and it all comes back, and you get
primary, secondary, tertiary reflections.
Exactly,
all that stuff.
And I mean, that's the kind of thing that helps you understand where things are in space. Like, it's supportive reflections sometimes in a lecture theatre. If a lecturer is away and you get an early reflection, it might help you, whereas reverberation in a room might be bad in some other instances. This is a space that's designed to have none of that, because what we want to do is hear what a transducer is actually doing. So you've got a microphone, you want to know what that microphone is hearing when a sound is played out of a speaker. And what you don't want to know is what the microphone's going to do when the sound bounces off a wall and off the ceiling and everything else. So if you want to know the directionality of a microphone, for instance, like we got our shotgun mics that cancel sounds from the side, pick up in the front, we want to know exactly what it's doing at each frequency. And the only way to do that is to play a sound in this room through the mic as you kind of turn it around, and you'll see the roll-off pattern of what it's actually picking up. And that's how you build those polar charts that you see every time you look at a microphone specification sheet.
So how high of frequencies do you play in here?
So we'll play, just about every frequency you'll see on a test chart. So often we'll spec microphones up to 16 kilohertz.
16?
Yeah.
Wow.
Yeah. So, humans can hear up to 20 kilohertz if they've got, good hearing like they did when they were born. Yeah. Right. A lot of us wouldn't have that. Even by the time we're about 20, you'll be losing your high frequencies, or if you've been to a lot of loud concerts, then forget about it. You probably lost a lot more than 20K off the top. But it's kind of not about how high the frequency is. It's about knowing what a microphone does at certain frequency bands. So we'll test it at 500 hertz, at 1,000 hertz, at 2,000 hertz, and that will give you as a user an idea of what it's going to do to, say, a voice that's coming in from the side. Is it going to cancel out that voice? Is it going to cancel out the high frequencies and the low frequencies, or just the low frequencies? What's the microphone going to pick up from behind? So if you want a cardioid microphone that rejects sound from the rear, you want to look at that polar response chart and go, is it rejecting sound from the rear at all frequencies? Or can I live with it maybe not being quite so directional at lower frequencies? We can test all of that in this room, and that gives you, as a user, an idea of what that microphone is doing. And that's how you spec up a microphone for the right situation.
So for the construction-minded and interested, what is this stuff made out of?
So this is a kind of fiberglass that's at different kind of densities as it goes through. The idea here with these wedges is that they're going to cancel out sound as it goes in. It'll reflect around and disappear. There is a lower limit to what it will cancel. This room is rated to around 100 hertz. And this would be the quarter wavelength of 100 hertz, basically.
Right.
That is more than enough for our kind of applications with microphones, especially a lot of microphones that are designed for singing or for broadcast speech recording.
So you're not banging 40 hertz through this room and hoping to get some kind of a...
No, exactly right. And especially with microphones, such as what we're using. We've got high-pass filters on a lot of our microphones where you're cutting out a lot of low frequency.
Sure.
And that's 100 hertz for a perfect cancellation. You then still have, some absorption at lower frequencies below that.
Oh, right.
But for instance, to have a chamber that would cancel out all the way down to the lowest range of human hearing, which is 20 hertz, these things would be meters long.
Yeah, 4 or 5 times as long.
And the room would still be the same size internally. The wedges would just go out much further, and you'd need a lot more space.
Right. So did you build this?
So we actually had this chamber designed and initially manufactured in Canada.
Oh, wow.
And it was shipped from there all the way here in Australia in about 4 40-foot containers.
Whoa.
And then the designers, the original acousticians who designed it, came out and kind of oversaw the construction of it. We had a lot of our own team come and help out. I mean, you can see this floor is like a woven kind of suspended floor, and below that you got more of these wedges, and the idea is that you want to cancel out everything all around.
Right, because if this were just flat, then you've got a huge reflection coming up and all of this, right?
So,
So this was cheap to build.
Absolutely not. But,
Super inexpensive.
Super expensive, but it's kind of the holy grail for a microphone manufacturer to have a really good anechoic chamber, because this is where you find out what your microphone is doing. This is how you design a good microphone. You know, if you want to design a mic that has a particular characteristic, even the frequency response of the mic, we can play a frequency sweep out through a speaker, pick it up in front of the mic, and we can know what the mic's doing.
Wow.
For instance, if you did that same sweep in a stairwell, have you ever noticed when you're standing in a stairwell how you hear that like really woofy kind of tone, like the low frequencies are bouncing around because there's a standing wave in there? What would happen on a microphone is if you put a frequency sweep through, it would tell you the microphone's picking up heaps of bass, even though it's not really. It's the room, the space is reacting. This space won't react to those frequencies. So, so we can hear what the microphone's actually hearing.
Wow. So how many microphones do you test in here in a year?
So we don't test every single microphone in this space. And this is more of a design and verification space. So we'll every single microphone that every new capsule that we design, every body that we design is tested in here. It's kind of designed in here. It's made in here. And then we'll batch test microphones. Every time we do a production run, we'll test one out of the batch because we've verified them all electronically. We've done the kind of spoken test, and we'll actually test the microphone to make sure that it's up to spec in terms of its frequency response and its actual polar pattern, the cancellation.
Sure.
Kind of increasingly more microphones as we go, because we've got more microphone models all the time.
Sure.
But yeah, it's one of those things where we have to verify that the microphones are being manufactured, to our spec, and we can do that in this space.
So can I get Rode to build me one of these in my house?
I'm sure we could put you in touch with the acousticians who designed it.
That's great.
But for sure, I mean, it'd be a nice meditation space.
Yeah, right. Just a little space in the floor there and get down. Ryan, thank you so much for taking us through this whole massive facility. It's been an incredible education to know basically from stem to stern how a microphone is built here at Rode and how much care Rode takes in making sure we have the quality microphones to get out.
Thank you very much for coming. It's been a pleasure.
Yes, sir.
Cheers.
Cheers.